Good evening, class. Welcome to Gen X students. Today is the 10th session of our course, and till now we are currently doing our third chapter, that is square and square roots. In the previous classes, we have discussed rational numbers and playing with numbers. So the third chapter is square and square roots, and this is the third class out of four for square roots, square and square roots. So till now, we have done introduction, properties of square numbers, some interesting patterns, finding the square of a number. And yesterday we could complete most of the portions for square roots. So in today's class, we are going to continue with square roots. All right. So yeah, the topic square root, finding square root has been divided into 4 to 5 sessions. So yesterday we did 5.1, which says finding square roots. Then we moved on to finding square root through repeated subtraction of odd numbers. So today we will continue the class with 6.5.3, finding square roots through prime factorization. Yesterday I gave you a brief introduction about this topic, prime factorization, and what we are going to do. So today let's discuss what is a prime number. So a prime number is a number which has only two factors, the number itself and one. So in other words, you can say that a prime number is divisible only by itself and one. So you can say that in terms of factors, or you can say in terms of divisibility. So let's take an example, 3. We say that 3 is a prime number. Why? Because 3 has no factors other than 3 and 1. 3 into 1 is 3, 1 into 3 is 3. Again, in the second statement, I told you that a prime number can be is divisible by itself and only 1. So we have 3 divided by 3 is 1. 3 divided by 1 is equal to 3. So we have no remainder, meaning 3 is divisible by 3 or 1. So 3 satisfies both the conditions, and that's why we say prime 3 is a prime number. Similarly, we have prime numbers such as 2, 3, 5, 7, 11, and so on. Let me remind you, 2 is the only even number which is a prime number. The rest of the even numbers are not prime numbers. So what do we call these numbers which are not prime numbers? We call them as composite numbers. Okay. So moving on, we have prime factorization. So what is factorization? Factorization says that any given number can be expressed in terms of factors of prime numbers. For example, if you take 36, 36 can be expressed as 6 into 6. But is 6 a prime number? No, because it has more than 2 factors. So what do? We take 36 and we try to find its prime factors. So we express 36 into 36 as 2 into 2 into 3 into 3. So 2 and 3 are prime factors, and hence we call this process as prime factorization. 6 is expressed as a factor of 2 and 3. 2 and 3 are prime factorization. Now, prime factorization of its square. Here you see a table in your book where they have divided into 2 columns. The first one says prime factorization of a number. Again, in the second column, they say prime factorization of its square. So they take 6. 6 is expressed as in factors of 2 and 3. Moving on, 6 squared gives us 36. 36 can be expressed as a prime factor 36 can be expressed in terms of factors 2 and 3, where 2 is repeated twice and 3 is repeated twice. So we say that 2 square into 3 square gives us 36.